In this video, we are going to solve systems of linear equations by graphing. In math, a system of equations is just a collection of two or more equations. These equations can be represented by lines on a graph. The common point where the lines intersect is the solution, because it is the point that makes all of the equations true at once. This visual method of solving a system of equations will help us better understand the more algebraic methods we will learn about later. Now here we have two equations. So this is a system of equations, and we are going to solve it by graphing these two equations. Now in the first one, we have a slope of 5 and a y-intercept of -1. I will start with the y-intercept. And from this y-intercept of -1, I have a slope of 5, which means go up 5 over 1. I'm going to go up 1, 2, 3, 4, 5. So up 5 and over 1. That's the slope of 5. All right, so I have the first equation graphed. On to the next one. We have a y-intercept of 3 and a slope of 1. Slope of 1 means go up 1 over 1. So let's start with the y-intercept at 3. And from that point, we're going to go up 1 and over 1. All right, now we have graphed the system of equations. And we see that the lines intersect at the point 1, 4. And that point is considered the solution to the system of equations. Because if we plug in 1 for x and 4 for y into the equations, those numbers will make both equations true. So we have a solution of 1, 4. Here we have another system of equations. This doesn't look like much of a system because these two equations are exactly the same. So when we graph them, they both have a y-intercept of 1 and a slope of 1/2, so up 1 over 2. All right, it seems kind of silly to have two equations for the same graph, but the point here is that all of the points along this line are solutions to this system of equations. So that means we have an infinite number of solutions. So in that case, we're going to type the infinity symbol for our solution, because we have infinitely many solutions. Now in this system of equations, both lines have the same slope, -1/4, but they have different y-intercepts. So in this first one, I'll start with the y-intercept of 1, and from there, from that point, I need to go down 1, right 4. Now in the second equation, we have a y-intercept of -3, and from that point, I need to go down 1, right 4. And we notice we ended up with a pair of parallel lines. When you have two lines with the same slope, they never intersect. So in this case, no solution exists. So we can just type DNE for does not exist. The lines never intersect, so they don't have a solution. Now in this system, we have an equation that just says y equals 2. Well, that means that no matter what x is, y is always 2. So it'll have a y-intercept of 2. And any other point along this line will have a y value of 2. So no matter what the x is, y is always 2. This other equation has a y-intercept of 1 and a slope of -1/5. So from the y-intercept, I'm going to go down 1, right 5. And I see that the lines intersect at the point -5, 2. So that's the solution. It's the one point that is true for both equations. Now here we have a system of linear equations already graphed, and we need to write the equations. So in the graph with the positive slope, we notice it has a y-intercept of -6, and from that y-intercept, going to the right, to get to the next point, I go up 1, 2, 3, 4, and over 1. So up 4, right 1. That's the slope of 4. So I have y equals 4x minus 6. Now for the graph with the negative slope, we have a y-intercept of positive 4, and the slope is -1 because we go down 1, right 1. Now when the slope is 1 or -1, we don't need to write the 1. We understand it's there. So this graph matches the system of equations y equals 4x minus 6 and y equals -x plus 4. Here we have another system of equations. For the line with the negative slope, we notice that it has a y-intercept of 4. And from that y-intercept down to this next point, we go down 1, 2, 3, 4, and over 1. So it has a slope of -4. So the equation is y equals -4x plus 4. For the line with the positive slope, this one has a y-intercept of 3. And sliding from that y-intercept up to the next point, we went up 1, 2, 3, 4, and over 1. So this one has a slope of +4. And we have our system of equations. I hope these examples have been helpful. This is Mr. Ela signing off.